welcome to DSA Weekly Module 1 challenge solving session. In this video we will be solving our first problem, that's the easy one of the mathematics submodule. So let's begin, let's head into it. What we can see is the problem's called digits in factorial, and here's the problem statement. So you're given an integer n. We need to find the number of digits that appear in its factorial. So obviously we all know what a factorial is. A factorial is something, a factorial of a number is basically 1 to that number, multiplied 1, 2, 3 and to that number, and multiply all those and you get the factorial. And there's these pretty basic formulas. Factorial of 0 becomes 1. It's a property of mathematics. And factorial of n becomes 1 multiplied throughout that number. Alright, so let's take an example. So we have an input of 5 and our output comes out to be 3, because 120 is the factorial of 5 and 120 has how many digits? 3 digits. Okay, cool. Now n becomes 120 and we have an output of 199. So just imagine 1 se leke 120 tak you are multiplying all the numbers and you get the factorial of 120, which has 199 digits. Now many of you can think of solving this problem very easily using a for loop. How is that? Well, just calculate the factorial of a number, run it through a for loop with a counter set to 0, increment in every step, and you get the answer. It's pretty easy that way. It's a naive approach. But the problem is that we have the order of n is large. As you can see, 120. So 120 factorial, that is a huge number. So how do we deal with that? Well, let's try out the naive approach first, see what happens. Alright, so let's begin with the naive approach. So we just need to define a few things. First of all, the factorial of n is nothing but 1 multiplied by 2 multiplied by, and we go on to n. Simple as that. And we have f of 0, which is just 1. That's a mathematical property which is defined, right? Okay, so what we could do is basically find out the factorial. So we can write a function called fact of, well, we'll send in the argument of n, and what it will do is basically either you can use recursion to run a while loop and just calculate the factorial, or you can also use the built-in libraries in C++ or Python. Yeah, so that way you can find the factorial and just run a for loop. So what it will do is that in every iteration it will, let's say the number is 120, right? The factorial of 5. So this is 120, and what it will do is that it starts from I equals 0. So it will get a hold of this one first, then we divide the number by 10 and we get its floor value, so 12. So our counter now was 0, right? It started from 0. Now it becomes 1. We go to our next step, we get 1, right? Because we're dividing it by 10 and getting the floor value. Yeah, and then we get the counter of 2, right? So technically then we divide this number by 10 and we get 0. Ultimately our counter becomes 3. This is the naive approach. This was very easy to do, right, with a pen and paper. But imagine your number is n, which is so big, like 120. That's a big number, n, right? You're getting 199 digits. We can't do that. Even for a computer, that will be, that will be very costly, both in terms of space and time. So let's try a different approach. Alright, so what if our naive approach is not working? What should we do? Well, it's very easy. Let's just clear this first. Alright, so what we'll do is we'll use the power of logarithms, right? Logarithms are very powerful. What are logarithms? So let's just revise basic properties. I'll just use text here. So if I'm saying log, right, what does it actually mean? So log, let's say we want to calculate the log of 8. and we know the base is 2. Let's just revise a bit. So what this technically means is that if I write 2 to the x equals 8, right, what is x going to be? We can use our intuition and our mind and can tell x is 3. 2 to the 3 is 8. So the value of log 8 to the base 2 just becomes 3. Easy property, yeah. One very more important property would be, what if you were to have a log of say a times b, right? So it will be log a plus log b, right? It's pretty trivial. You can look at it. What you're doing is just multiplying a and b and you get log a plus log b. We'll use this to solve a problem. So we know that n factorial is just 1 times 2 times 3 and so on till n. What if we were to put log in it, confine them under the log function? So what you get now is, using the property we just learned right here, right, log a times b is log a plus log b. What if we had log a times b times c times d, just individual logs and just sum them all, right? So this will be log 1 plus log 2 and plus log 3, and we're just summing it up and ultimately we get to log n, right? Pretty basic property, right? Okay, so what are we getting through this? Just a minute. Yeah, that's fine. So what can we see here? It's a pretty good observation. The log of the number you're trying to take, if you observe, the number of digits of a factorial of a number n is basically the floor value of the logs plus 1. Okay, what does that mean? We'll see. Yeah, so the floor value, it just gives us the floor value of the complete log plus 1 gives us the number of digits. Let's try to test this out. So it's pretty easy. I'll just keep this here. Okay, so we have log n factorial. Let's take the value of n as 5, right? The question we had. So in this case, log n factorial, which is 5 factorial, it just becomes what? It becomes, it becomes log 1, becomes log 1 plus log 2 plus and so on till log 5. Now if you were to calculate the logs of each number, right, so we could just use a calculator. I'll use mine. So log 1 is 0, it's just a property. If I were to find out log 2 plus log 3 plus log 4 plus log 5. So what we find is, by doing log 1 plus log 2 plus log 3 till log 5, the value we get is 2.07918. So we could just round that off to 2.08. I'm just going to write that down. Yeah, and just to keep in mind, the log I have taken is not natural log, it is log to the base 10. The reason we are doing that is, if you imagine, what does 10 represent? It represents decimal, right? So we're going through each digit without actually going through each digit. We're just calculating the log, and this powerful property gives us this number, and we'll upload the floor function on it. What's the floor function? Floor function, what it does is that if you have a number, let's say 2.08, it rounds it off to the floor value. There's a ceiling value and a floor value. So the ceiling value of this number would be 3 if you're talking about integers, and the floor value of this would be 2. So in this case our floor value is 2, and just do that plus 1, and what you get is 3. That's our answer. That's the best approach we can use, because it uses logarithm, and the time complexity does not go over linear time, that is O of n. Let's try to do this in code. Alright, so let's code now. First what we'll do is we'll define a function which basically will return the count of the digits. So let's call it find count, and we'll give it a number n as a parameter, as an argument. right? Now what we want to do is, obviously when we are given a number n, we want to check if it is under the constraints that we have defined. So what happens if the number is less than 0? Let's account for that. So if the number is less than 0, what we'll do, we'll just return 0, because a factorial, negative factorial doesn't mean anything, the factorial of a negative number. Okay, fine. What if the number is 0? What about that? So if it is 0, we'll just return 1. Easy, right? Now, yeah, I just forgot to do one thing. We also need to account for 1, because if the number is 1, then it returns 1. So we'll just write this. Pretty easy, right? Now let's move on to the main part of the problem. So here what we'll do is we'll run a for loop that will just add up the logs, the individual logs, right? Let's first let's declare a variable called digits, right? Or we could make it value, yeah, double digits, right? Now we run the for loop. So now what we need to remember is we need to run our for loop from 2. The reason is that because we already have put on cases for 0 and 1, so we start from 2. So for int I equals 2, we will go on till n, so it's 2, 3, 4 till n, right? And we'll just increment. And what we want to do, I will not use a curly brace because we just need one line. What I want to do is I want to add into digits, right? Sum into digits. What do I want to do? So as you can see, I've already used the bits std C++ library, which is used in competitive programming IDEs like CodeChef and LeetCode, right? What I want to do is I want to find out the log to the base 10 of what? Of I. Make sense? Starts from 2, 3, 4, 5 and whatever n is, and it goes till there, and it basically just sums up till, starts from 0 and sums up till n, right? Now we got our digits. What we want to do now is, let's call an integer, or we could just return. We'll return, so we'll use math.floor, which already comes in this library. So return floor. Floor of what? The floor of digits. And as we observed, we just need to increment a 1. Okay, I think that works out. Let's just put in a few cases and we'll just return, we'll just print out. So how about find count of 5? I will also use an endl here, so it just gives us a line break. And find count of, the number was 120, right? Yeah, let's take 120. Huge number, I know. Alright, let's just run this. There we have it. So we get the answer of 3, which was right in the case of 5, and in the case of 120 we were getting 199 digits. This is the best approach that we have now. A naive approach, it would have taken too much time and too much space, which is not what we want. So we use the logarithmic approach. So this is the code, this is the logic behind the whole problem. We hope you liked the video. The medium and advanced challenge tutorials will be coming right up.